Hey, awesome pre-calc. This is for this recording is for 4.2, example 1. Okay, so example 1 says use the remainder theorem, okay, to find the remainder when f of x, excuse me, is divided by x minus c. So f of x divided by x minus c. And then use a factor theorem. There are two theorems involved, okay? Use a factor theorem to determine whether x minus c is a factor of f of x. So let's go back. The last time we talked about the remainder theorem. So let's go back and look at what the remainder theorem states. So the remainder theorem from last time is all the way up here, okay? Here we go. Let f be a polynomial. So let f be a polynomial function. If f of x is divided by x minus c, then the remainder is f minus c. So what does that really mean? It means that if this is a factor, if we're dividing by that, that's the same thing as just plugging in a c value in the function itself. So it says, hey, use the remainder theorem first. So that's what we will do. Here we go. So for this one, here is x minus c. Okay. Well, what does that mean? Well, then that means c is what? C is what? What will make this a positive 3? C would have to be a negative 3, okay? So how does that work? Let's test it out. X minus a negative 3. Two negatives will make it a positive. So C is always the opposite, okay? If it's x plus 3, then C is a minus 3. If x minus 3 is really what we are dividing, then the C is just a simple 3, okay? So it's the opposite. All right, so it says use the remainder theorem, okay, to find the remainder. Well, to find the remainder, based on that, is we're going to plug in f of c. Well, c in this problem is negative 3. So here we go. 2 times negative 3 to the 6th minus 18 times negative 3 to the 4th plus negative 3 squared minus 9, okay? Well, I trust that you're going to have a calculator, so I will take out my graphing calculator and punch this in. So enter the whole thing in my calculator. So give me a second to enter that. So 2 times negative 3 carrot to the 6th power minus 18 times negative 3 to carrot to the 4th power plus negative 3 squared, that's really 9, so I'm just going to do 9, take away 9, ooh, 9 take away 9 is nice. Oh my gosh, you know what f of negative 3 is? It's 0, okay? So what does that mean? The remainder is nothing. You have no remainder, okay? I'm trying to pinch this in, okay? So the remainder is 0. Remainder is 0, or you can even say no remainder. Okay. Then it says use the factor theorem to determine whether x minus c is a factor of f of x. Okay, let's go back up to kind of remind ourselves what a factor theorem is. So remainder theorem, factor theorem. Let f be a polynomial function. Then x minus c, which what we saw, is a factor of f. If the remainder is 0, what? Okay. Now on the right-hand side, it says number 1. If f of c equals to 0, then x minus c is a factor of f of x, which in our problem, that is definitely true. Now we can also go backwards and say, hey, if x minus c is a factor of f of x, then when you plug in what c is, it has to come out to be 0. So in our case, okay, since the remainder is 0, based on the factor theorem, we can say that x plus 3, okay, is a factor of f of x, okay, which is this equation right here. So minus 18 x to the 4th plus x squared minus 9. So that is what we have. So we have to box two things. Find the remainder. You can box no remainder, or you can box the remainder 0. And then make a statement. X plus 3 is a factor because the remainder is 0. Okay. All right, let's do B. So x plus 1/3 is what they gave you. That means C is the opposite, which is negative 1/3. So to use the remainder theorem, we will now plug in f of c. In this problem, c is negative 1/3. So we are going to slowly punch this in. Here we go. 3 times negative 1/3 to the 4th plus 1/3, negative 1/3 to the 3rd minus 3 times negative 1/3 and bring down the 1. Negative 1/3 to the 4th, that would definitely be a positive number, okay? So 1 to the 4th is still 1, okay? But 3 to the 4th is now 81. The negative 1/3 to the 4th is now negative, so this is negative 1 over, okay, 27, because 3 to the 3rd is 27. A negative times a negative is now a positive. These will cancel, so that will give me a 1 and drop down the 1. I can definitely cancel the 3 into the 81. So 81 divided by 3 is now 27. Okay, so bring this down. All right, so 27, take over 27 is, ooh. So look, you have a remainder for this one. So remainder is 2, okay? So what does that mean? When I take this and divide it by, when I take f of x, okay, and I divide it by x plus 3, okay, x plus 1/3, I'm sorry, x plus 1/3, you're going to come up with a remainder of 2. With the remainder of 2, okay, the factor theorem said x plus 1/3 is not a factor of f of x, okay? It's only a factor of f of x if the remainder is 0. And this is the end of our recording.